So I made a surprisingly simple bike power generator from materials I had laying around in my garage. The bike is just an ordinary road bike. The trainer is something I got from the DI a few years ago for probably only $5 or $10. The motor is from a treadmill that I scrounged up for free. These supplies I'm pretty sure everyone either has or could get pretty easily from their local thrift store. The other two important pieces are this variable input 12-volt regulator and a 450 watt power inverter. Getting these from Amazon would run you about $80 total. Fortunately for me, I had both of them from previous projects. I toyed around with several possible ways to attach the motor to the bike trainer, but since I wanted to keep the design as simple as possible, I decided to attach it in such a way that the tire would contact the flywheel directly. Fortunately, this treadmill motor has some built-in attaching capabilities, so it was pretty easy to make some custom wood pieces to hold the motor up and attach it to the base. Combining that with some built-in brackets from the bike trainer, I was actually able to make it slightly adjustable for different sized tires. Lastly, I just need to secure the bike trainer to the base to make sure it doesn't slide forward or backward. And then I'm in business. The wiring is super straightforward. The output from the motor goes into the input of the 12-volt regulator, and the output from the regulator goes into the input for the inverter. From there, you just plug in whatever you want and see if you can power it. Just in case you notice the battery in this clip, let me assure you it's completely superfluous. The only reason the battery is even here is because the first bicycle powered generator I made used a car alternator, which required the battery because it does not have a permanent magnet. After I shot this clip, I realized I didn't need the battery anymore, and I didn't use it again for the rest of the clips. My roommate and I had a good time trying to figure out what we could power.
This one I don't think you'll feel much. You'll feel the difference, but I don't think it'll be like stark. Okay, so first I turn this on.
Oh, I can feel it.
Go faster and then it'll get easier, yeah. As long as you're supplying enough to keep this on. Okay, but it will get harder when I plug this in. Ready? You didn't really feel it?
These 9-watt bulbs are no problem.
Yeah, the vacuum cleaner was the next thing I found.
You're putting the vacuum cleaner on?
I don't think you're going to be able to do it, to be honest.
That's going to draw a lot of power.
Yeah, it's probably...
This shop vac? No way. Even if my roommate had enough power output to power it, my inverter's not even rated that high.
And good luck.
Same with the blender.
Do you have a blender?
Yeah, I've got a blender.
Oh, you had one in hand?
I had it in my hand. I was walking down the stairs with it. This will be funny because you're taking your rotational motion, converting it to electrical energy, and then converting it back into rotational motion. Here we go. Nothing's happening.
Yeah, believe it or not, the blender was also in the 500 watt range. This 50 watt soldering iron was pretty fun. Still pretty doable, but enough that my roommate could feel the difference instantly.
You won't, but I bet you'll feel it pretty instantly.
Oh yeah, I can feel it.
Go, you can do it. You're doing it.
I'm doing it, Pete.
Finally, we found an arrangement with 2 bulbs, a soldering iron, and a hot glue gun, which came to about 90 watts.
Yep, I can feel the load now.
See if you can do this for a couple of minutes.
90 watts is enough that you can do it, but you start to get tuckered after a minute or two. In my experience doing this with multiple people, it seems like about 100 watt output is what most people can sustain for any length of time. Since an average home can be drawing anywhere from 1 to 2 kilowatts at any given moment, this is no substitute for grid electricity. But it is a fun way to get a more intuitive sense of energy usage over time.